So today I'll go ahead and start with a sort of short and brief review of what I covered last time, just to refresh your memory. What is statistics? I kind of look at statistics as the study and analysis of data. Okay, statistics is the study and analysis of data. In statistics, when you study statistics, you're kind of like doing a three-step process. Step one, you're collecting data. Step two, you're analyzing the collected data. Now you can use different mathematical methods or procedures to analyze your data. Now, based on your analysis in step three, you make either conclusions or you make predictions. So this is the broader strategy that you follow. You collect data, you analyze data, and based on your analysis, you make conclusions or predictions. And statistics is the study and analysis of data. There are two types of statistics we talked about. One is descriptive statistics, where you describe the data through visual means most of the times, okay? You look at the data from different perspectives, different angles. You can express data or put data in the form of tables, graphs, charts, or histograms. That's one familiar way of doing it, even though there are other more sophisticated visualization tools available. But these are basic visualization tools that pretty much everybody knows, okay? Then also you may look at the shape of the data, which is kind of like the distribution of the data. How does it look like? And variation of the data, you can look at it, how far apart the data points are with respect to each other, or how far apart the data points are compared to where most of the data points are. So compared to the center of the data point. So if you have a collection of data, you have most of the data at a certain point, right? How far apart they are. Here, I kind of want to give you sort of like an example that would really help you. So think of this. This is a bell-shaped curve, most common curve that we'll be using throughout the semester and probably the most useful curve. So you can see the most of the data points are right around here, right? Okay, right around here, you can see. Most of the data points are right around here. However, let's consider another bell-shaped curve. Oops, not that. This is kind of like a bell-shaped curve too. Again, the most of the data points are around here. However, just by looking at these two shapes or two distributions, you can see that data points in this shape, okay, in this set, are more closer to the center or closer to each other compared to this one, where the center of the data set is somewhere here. However, the data points are further out. So that is the variation, okay? And you will learn very quickly the variation in the data set is measured by something called variance, okay? However, for ordinary people or for regular people, we don't use the word variance so much. We use something called standard deviation. You learn that. Standard deviation. You will be measuring the spread of the data set by using something called standard deviation. And I will walk you through the steps of standard deviation. Step by step, we are going to do problems so that you can understand it, okay? For now, think of standard deviation as something that basically tells you how far apart the data points are, how far away the data points are. Are you guys okay so far?
Yes.
Yeah.
Okay, good.
Yes,
Thank you. Inferential statistics is something where you infer or make conclusions or predictions based on your analysis. And some of the things we will be talking about is called confidence intervals and hypothesis testing. Confidence interval is something, I'll give you a very simple example. Let's say I ask you, what is the average income for students at Ordinal College? How much money they make, okay, on the average? I'm talking about people, students who are like, ordinary students who probably work here and there and make some money. I'm not talking about extreme values, okay? Extreme values in statistics, by the way, is called outliers, okay? Remember this term. This is a statistics term. Extreme values means outliers. It could be extremely large or extremely what? Small. So now, when I'm talking about what is the average amount of money Hartnell students make, I'm not including a student who just inherited $1 million. That's an extreme value. We are excluding those. So you go out and survey, let's say, 100 people, and you find that, on the average, they make about $800 a month. I just made up that number, okay? Based on this number, you kind of guess, oh, okay, I surveyed about 800 students, randomly selected students, and I found that their average is $800. Now, maybe the real average for the Hartnell College could be as low as $700, maybe. Subtract $100 from it, or add $100 to it, $900. This is an estimated guess, right? You always do this kind of calculations in your head. You surveyed and you found 800, but you're guessing that it could be between 700 and 900. You go 100 lower than 800 and 100 above 800. So you just created an interval. This interval is called confidence interval. Okay, this is a very important concept. Based on your statistical study, using some mathematical procedures, you come up with an interval, okay, that is likely to contain the actual average for the Hartnell students. That is called a confidence interval. And there is a process for doing so, and you will learn it. And similarly for hypothesis, there is a process for testing a hypothesis. For example, you're claiming Hartnell students make $800 a month. That's your claim. Now, is it something valid? You can test it by doing hypothesis testing. So this is more along the line of inferential statistics. Okay, since this is the kind of like barely the second class, I'm giving you a little bit more introduction or summary of the last class. In general, I will not be giving so much detailed summary, but you're just getting used to, so that's why I'm trying to help you out a little bit more. And then we talked about data. Remember, data we have defined as information. Do not think data as numbers, even though data could be numbers. So data could be numbers, but data could be non-numbers too. Data could be qualitative also. Qualitative data could also be called categorical data. People sometimes call it categorical data. So data is the collection of information from the items under consideration. And those items, again, the word items, it covers a broad range. It could be anything. It's not human beings only. It could be cars, it could be trees, it could be the stars in the sky, or it could be the economic data, or it could be the stock market data. It could be anything under the sun or in the universe. There are two types of data, qualitative data and quantitative data. As the names imply, qualitative data, it describes some attributes, characteristics, or property, okay? That's qualitative in nature. It is not numerical. That's one of the things. Even though I gave you examples where numerical data could also be qualitative, like your social security number, like the numbers on the basketball players or football players. Those are qualitative data. Now, normally qualitative data has some sort of quality or associated with it. So for instance, I could say immigrants versus non-immigrants. That's a quality. Christians versus non-Christians, okay? Then it could be people in different economic groups, like wealthy, average, poor. It could be based on religious faith, Christians, Muslims, Hindus, Jews, Buddhists. These are attributes, qualities. Or it could be cars, different types of cars, like Ford, GM cars, okay, Chrysler, or Mercedes, BMW, Volvo. Do you see? These are categorical data. Or information about different cities in the county of Monterey, Salinas, Monterey, Seaside, then Prunedale, King City. These are information about different cities. So these are qualitative in nature or categorical. Okay, next, quantitative data, as the name implies, is numerical in nature, okay? It's numerical in nature, and you can apply the usual mathematical operations on those data, add, subtract, multiply, divide, etc. Those things are typically going to make sense. But in qualitative data, you cannot add to qualitative data. You live in Salinas and somebody lives in King City, you cannot add these two, okay? You cannot say I'm adding Salinas with King City. All right, now quantitative data could be further divided into two groups, okay, which is discrete and continuous. Discrete data, remember, the main property is countable. It's kind of like the whole numbers, 0, 1, 2, 3, 4, etc. Discrete data. And then you could have continuous data. Okay, continuous data, it comes from an interval on the number line. It comes from the interval, from an interval on the number line. The main characteristic of this set of data, this type of data, is that it is uncountable. Okay, continuous data is uncountable, and it will be normally coming from the number line. Okay, here it is. So if you have the number line 0, 1, 2, 3, etc. -1, -2, -3, and keeps going. So that's the summary of everything that we have covered. Are you guys absolutely comfortable with it?
Yes.
Okay, good.
Yes, thank you.
Yes.
Okay, slowly I'll get to know you guys. So it's just the beginning of the semester. I'll know you at least by name, okay? I don't see you, you don't see me, but I'll know your names. And sometimes I'll ask people to participate, so don't be shy about it, okay? Next, now we're going to talk about the new topic. What is it? Okay, we talked about that. Levels of measurements. So this is an important topic. Statistics is about analyzing data, right? And we know data is collection of information. Statistics is about collecting and analyzing data, studying data. And data is actually information. Now, when you collect information from things that are of interest to you, you can collect information at different levels or different degrees. When you're collecting information, you can collect information at different levels or degrees. And those levels are called levels of measurements. For instance, I just want to give you some simple example. Let's pick a student. Okay, Aldo Chavez. Okay, so your name is first. That's why I called you Aldo. So he's on the first at the beginning of the list. I have all the students who are participating here. So Aldo.
Yes.
So I could collect data from you. Like, what is your name, Aldo?
Aldo.
That, huh?
Yeah.
Aldo. Your name is. Am I pronouncing it right or Aldo? Aldo.
Aldo, but I like to be called Ali.
Ali?
Yes.
Okay, Ali. So what's your name? Ali. So I'm collecting some data. All right. So that would be nominal, like labeling. Okay. Now, I ask Ali, what grade would you like to receive in this class? So give me an example grade that you'd like to receive, Ali.
I would like to receive at least an A.
At least an A. So that's an ordinal type of information I am collecting from Ali. Why ordinal? Because he wants to get a grade A, B, C, or D, okay? Or F. These are all the possibilities. So as I give the example, keep an eye on what I'm doing, okay? So that'll walk you through the entire process. So this is ordinal. So why is it ordinal? He could get A or B. Getting A is better than B. Or he could get a C. Getting C is worse than getting B, right? Do you see? The information that I collected from Ali about his grades or intention of grade that he wants to receive in this class could be ordered, unlike the last one, nominal. Okay, what's your name? My name is Ali. Now, I ask him, what year were you born? Okay, so you don't have to answer that, Ali. Let's say Ali was born in 2000. Okay. Now I'm asking him something about like, oh, okay, the year where you were born. Now, if you look at this data, this is actually a time that I'm asking him about. So if he was born in, let's say, 2001, then he would have been 1 year younger. If he were born in 1999, he would be 1 year older compared to being born in 2000, right? So you can see, you can order this data that I'm collecting from Ali, like the last one, last grade. However, one thing you can do here, you can add and subtract. If you add 1 year, it makes sense. If you subtract 1 year, it also makes sense. But on the other hand, if you go back here and you say, oh, okay, I'm gonna say Ali got A, or he could got B, so A minus B or A plus B. That does not make any sense whatsoever. It does not make any sense. Adding and subtracting or multiplying two grades like A times B or A divided by B, does it make any sense in terms of grades? The answer is no, it doesn't. So in this case, you can order the data sets, right? This type of measurements, you can order it, but you cannot add, subtract, those things don't make sense. Here you can order it and also add, subtract, okay? Next, let's go ahead and move it slightly. I ask Ellie, okay, tell me how tall are you? All right, I ask Ellie, tell me how tall are you? So he gives me something like 5 feet 6 inches. I just made it up again. Ellie is 5 feet 6 inches. Now look at this data. If Ellie were to be 6 feet, then Ellie would be taller than this. If Ellie were to be 5 feet, Ellie would be shorter than that. And the difference between 6 feet and 5 feet is 1 feet, right? 1 foot, right? Or let's say we are comparing Ellie with somebody who is, let's say he's 6 feet tall. Ellie is 6 feet tall, and then somebody 3 feet tall. So it makes sense to say that Ellie is twice as tall as this person, or the difference between Ellie and the other person is 6 minus 3 is equal to 3. So in this type of measurements that you're doing, you can not only order, you can add or subtract and multiply or divide. All of this makes sense. So ratio level measurements is the most inclusive or most encompassing type. Inclusive or it encompassing type of data you can collect. As you can see, as you go down this list, you are collecting more deeper and deeper levels of data. Look, let me just put it all together. In nominal, you collect about names, okay? Ordinal, you collect data about something where you can order things. In nominals, ordering doesn't make any sense, right? It's just a name. If I were to ask somebody else, hey, what's your name? My name is John or Jessica. Ordering doesn't make sense. It could be Jessica, John, and Ellie, or Ellie, John, Jessica. It really doesn't make a difference. On the other hand, if I ask about grades, A, B, C, D, and F, these are the possible grades one can receive in a class. Now, you can order these grades, A being the best, B being the second best, third best, fourth best, and fifth best. Or F being the worst grade, second worst, third worst, fourth worst, and fifth worst. Do you see? Ordering makes sense, but it doesn't make any sense whatsoever to say A minus F, or A plus F, or A times F, or A divided by F. Okay, so that's the ordinal. Now, for next is the interval type. What is the interval data? Basically, you are collecting data at a level where not only you can do ordering, but also you can add or subtract. It makes sense. However, you cannot multiply or divide. These don't make sense. In the final category, you're collecting such data where you can order, you can add, you can subtract, and you can multiply and divide. So you can order, you can add, subtract, multiply, and divide. You can do all of this. It makes sense. And this is the most inclusive type of data collection you can do. Now, did it make sense to you guys? Are you feeling okay? Remember this example that I gave you. I'm collecting data from one student. What can I collect? If you remember this example, then that will help you understand all these things. Is it okay, guys?
Yes.
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 Okay.
Yes.
Now I have given you, I'm going to make individual videos for this too, which I haven't told you yet. I will make videos, not only that I'm recording these lectures, I have recorded these lectures many times and I delete them. But I'm going to make videos for individual topics, and it will be part of your homework to watch those videos and learn. So you have multiple avenues or opportunities to learn the concept, okay? Like I'll have one video about levels of measurement, okay, about this. So that will go over all the different levels of measurements, all right? Okay, now let's go ahead and go over these things again. Different levels of measurements we can make when we are collecting data is this. Sorry about that. I forgot to turn off my phone. I mean, put my phone in mute, sorry. Nominal, okay, where you're collecting names, labels, okay, qualities, like what city do you live in? Salinas, Monterey, Seaside, Prundell, Marina. So this is collecting information at a nominal level, okay? Now, ordinal level, where you're collecting data, where you're collecting data in such a way so that you can order the data, okay? Ordering of the data makes sense. One good example you could think of is your experience at bank. If you go to your local bank, you get their services, you can say that you have experience, you have some sort of experience. One being the best experience, two being the medium experience, three being the bad experience. Do you see? You can order it, but you cannot say 1 minus 2 or 1 plus 2. It doesn't make sense. So that would be examples of ordinal level of measurement. Now, interval level of measurement would be collecting data such that not only that you can order it, okay, but also you can add or subtract. It makes sense. Two examples of these things would be time, very common examples, and temperature. Now, instead of asking Ali what year was he born, I could have asked him, what is your body temperature? I could have done that. So he would say 98.6 degrees Fahrenheit, okay? All right. Now it could be lower, it could be 98, or it could be 99. Do you see that? So you can order these temperatures, highest, second highest, third highest, and the difference makes sense. 99 degrees minus 98.6 degrees is 0.4 degrees. It makes sense. Or 99 degrees minus 98 degrees is 1 degrees, right? It makes sense. So order, addition, subtraction makes sense, but you cannot do multiplication and division. These two do not make sense for interval. Now, the last thing is the ratio level measurement, where you collect data, okay? You collect data such that not only you can order, you can add, subtract, multiply, and divide. All of them make sense. And the key thing about this type of data, it has a natural starting point. The type of data you're talking about, it has a natural starting point. It has a natural starting point. So now think of height. Yes, please.
I'm sorry to interrupt. Were you gonna go into depth on what natural starting point means?
That's what I was going to tell you now.
Sorry, thank you. No, I apologize. I just
No,
was
that's
like,
fine.
Sorry, sir. Thank you.
What is a natural starting point? Again, Ali, he said that, let's say his height is 6 feet. Okay. So when we are talking about feet, that's the length. What is the natural starting point for length? There's going to be what? 0 feet, right? You cannot be less than 0 feet. So that's the natural starting point. If I ask you, what is your weight? Okay, there is a natural starting point of 0 pounds. If I ask you how much money you have, there's a natural starting point of $0. Do you see? Whenever you have a natural starting point for the type of data that you are collecting, then you can say that it's going to be ratio level measurement. One could argue with time and temperature. Technically, in theory, there is an absolute 0. In theory, there is an absolute 0 degrees, okay? However, for the practical purposes, we kind of exclude it. The reason is this. Let's say temperature in Salinas is 50 degrees. Temperature in Saudi Arabia is 100 degrees. You can say that the difference between temperatures between these two locations is 50 degrees. But you cannot say that, oh, it's twice as hot in Saudi Arabia as it is in Salinas. That kind of doesn't make so much sense. So here you do not kind of have a natural starting point, and that's why you cannot do these operations, multiplication and division. Or if I say in Boston, during the winter, it's 1 degrees Fahrenheit, okay? And in New York City, it is 2 degrees Fahrenheit. You couldn't say, oh yeah, it's twice as hot in New York City. It really doesn't make a whole lot of sense, right? So you kind of have to analyze your data and see if there is a natural starting point, and if it does make sense to do division and multiplication, and you will see most of the times. And also remember, statistics is a subject. You cannot always say that 2 plus 3 is equal to 5, like abstract, the math you are used to. It is not a precise 100%. There is a component of uncertainty. There is a component of randomness in statistics, okay? So make sure that you keep it in mind, all right? So some of that data collections, levels of measurements could be slightly overlapping or slightly treated differently depending on who is doing the calculation and how he or she is looking at the data. Now, is natural starting point clear to you? Yes? No?
Yes.
Okay.
Yes.
Natural
Yes.
starting point. Thank you. Natural starting point is where you naturally begin. Okay, that's what it is. And typically it is at 0. Okay, so that takes care of these levels of measurements. To summarize, levels of measurements. There are 4 of them, right? So let's create one. That's nominal, ordinal, interval, and ratio. I will try to create a table, but I haven't done so, but I will do it here. Here you cannot order, so no order. no, add, subtract, multiply, or divide. Yes, order. That means you can do ordering. No, on, add, subtract, multiply, or divide. Here you can yes, order, yes, add or subtract, but no multiplication or division. Here, yes on everything, yes, order, yes, on, add, subtract, multiply, and divide. And there is a natural starting point. I should have added this. So let's say I say NSP for natural starting point. No NSP, no natural starting point. I guess no NSP as well, because you can order them, but where does it start? Does it start at A or does it start at F? You could say A, B, C, D, and F, or you could say F, D, C, B, and A. And here, of course, no natural starting point. So try to remember these things. If needed, just take a picture of it. Okay, so that will help you learn these things. Okay, so now is it time to take a break yet? And we could go just a little bit more, then we'll take a little break. Okay, let's talk about the most common things, common verbiage, vocabulary that we use in statistics. So population is the word that we use in statistics to describe all the items or all the things that we are considering, everything under consideration for the study at hand. Okay, so it's the collection of all the items, things, or objects under consideration in a statistical study. Okay, so again, I mentioned here, I use the terms like things like items, things, and objects, because it could be anything. Okay, so you couldn't say, we are more used to thinking when you are younger, you're more used to thinking of data coming from humans. It really is not true. Data could be coming from, from product in manufacturing. As a matter of fact, there is a lot of data coming from manufacturing, and we use that data to improve the manufacturing process. You're in the ag industry here, right? So think of the data coming from the ag industry. What do they do? As a landowner or as a producer, you want to collect data about your process, okay? And based on the data, you make decisions so that you can improve your process. You can grow better quality lettuce or better quality produce, okay? And you are using data to make decisions, and that is why we call data-driven decision. This is very important, data-driven decision. Today's world, in today's business, we make data-driven decisions all the time. We did it in the past as well, but our collection of data is so vast right now. So much more data we have that we can make much more sophisticated decisions based on data. And as I told you the last time, the example of, someone's 16-year-old being pregnant, the father and mother doesn't know, but the manager at Target or some store knows that she's pregnant. Do you remember that? So where does it come from? It comes from data. So make sure that you do know how data is being used. Data could be used for good, and data could be used to manipulate things as well. We just recently had election, so data in election could be easily manipulated dependent on which network is presenting the data. They kind of twist it in their favor. But if you do objective analysis of data, it could be very meaningful, particularly in real world. All right, once again, population is what? Is all the items, things, or objects that are under consideration. Now, what is a sample? A sample is any collection or subset of the population. So a sample is a subset of the population. So think, if the people living in the city of Salinas is my population, all the people that live in Salinas, I am trying to collect data from them. So my population would be anybody and everybody that lives in Salinas. However, from that population, if I randomly select 1,000 people, there would be an example of a sample, because that 1,000 people came from the collection of people that live in Salinas. It is a subset. It is a smaller set. So when I say subset, subset means part of something, part of a bigger thing. Okay? It is a subset or part of a bigger thing, in this case, the population. So it is a sample. Now, I could be asking the question, let's say, in the city of Salinas, what is the average age of the people that live in the Salinas? Okay, so that means I'm trying to ask a question that involves all the people that live in Salinas. Okay, all the people that live in Salinas. Okay, so now that would be an example of parameter. That means you are describing some characteristic or some attribute or some property of the entire population, everything that you are considering to study, in this case, city of Salinas, or it could be our lovely city of San Francisco or San Jose, it doesn't matter. So that's parameter. And statistic would be a characteristic of a sample. Now, from the city of Salinas, if I took 1,000 people, okay, and found their average age, that number is describing the average for that 1,000 people. That means average for that sample. This 1,000 people, collection of information from this 1,000 people is sample, like sampling, right? Now, this characteristic, let's say their average age is, I don't know, 35, okay? 35 years. So this number 35 describes the property of a sample, okay, sample. Now, that is called statistic without the S. So pay attention to this. It is called statistic without the letter S. So sometimes we will use the word parameter, and sometimes we will use the word statistic without the S. So parameter will describe the property of the entire population, and statistic would describe the property of a sample. And you could take many, many samples from the city of Salinas, right? So each of these samples would have property, and that property would be statistic. Now, census, so you have heard of government census, right? You have heard of government census. Census means you collect data or information from all the items or objects in the population. When we say that we are doing a census, in theory, we collect data from everybody, okay? Everybody in the population. When we say we are taking a government census, That means we are collecting data from all the people in the country. In theory, we try to do so, or as much, excuse me, as much as we can, okay? In theory, we try to do so, or as much as we can. All right, so let's see. Sampling is the next topic. So I think this will be a good time to take a break.